So hello, my colleagues, and I hope everyone is well. So someone had an excellent question on Chapter 10, Problem 10 from the homework. And if you look here, in this section, on page, section, I guess, equation 10.7, the variance and volatility of returns. Now, you don't know the actual mean, okay? So let me read this. Looking at figure 10.5, let me click on that. So here's figure 10.5, right? And for different securities, T-bills, AAA bonds, S&P 500, and small stocks. All right. And here's the annual return for each. All right. So we can see that the variability of the returns is very different for each investment, and we just saw that, right? The distribution of small stock returns shows the widest spread. In other words, it has the largest variability or largest variance, right? The largest stocks of the S&P 500 have returns that vary less than those of small stocks, but much more than the returns of corporate bonds or T-bills. All right, let me go back there. You see how spread out this is? These are the small stocks. You see the large variation? And the S&P have the next largest, but you notice the T-bills are nice and tight. You don't get much variation in the returns. But in corporate bonds, you get more than T-bills, but not as much as you have with small stocks, okay? So I just wanted you to see that. To quantify this difference in variability, we can estimate the standard deviation of the probability distribution as before. We will use the empirical distribution to derive this estimate. Using the same logic as we did with the mean, we estimate now again, here's the important words, we estimate the variance by computing the average squared deviation from the mean, okay? I don't know how that got highlighted, but let me highlight this, hold on. All right. We do not actually, and here's the important words, we do not actually know the mean, so that means we don't know the variance. So instead we use the estimate of the mean, the average realized return. Okay? The average realized return. So this equation is a little different than the original variance equation you saw. So I tell you what, let me go back. Let me go back a couple of pages here in your textbook. All right. So here's the variance of the return distribution. Two common measures of the risk of a probability distribution are its variance and standard deviation. The variance is the expected squared deviation from the mean, and the standard deviation is the square root of the variance. So here's the equation for the variance, but you know the probabilities. You notice how there's two different variance equations here. You know the probabilities, okay? Now we're going to look at the second variance equation where you don't know the probabilities, okay? So let me go further. All right, now here's the second variance equation. Now you'll notice there's no probabilities here. We're just doing an estimate. You notice how there was a P for probabilities there? Well, it's not here. So this is the equation they wanted you to use for problem 10. The variance is the number of basically stocks, but you'll notice it's minus 1. Everyone see that? Minus 1. And then the sum from 1 to, let's say the total, T, RT minus the average realized return. So this equation is what they wanted you to use. I hope everyone's clear about that. Now, so from equation 10, let's look at table 10 too. Let's see if I can bring that up. All right, so there is, I don't know how many are here, but I don't know, 1, 2, 3, 4, 5. I don't know what they wanted you to see. A couple of years. Oh, 2005 to 2017. Okay, so I think there was 13 years there. Let me go back. So everyone's clear. Let me go back. let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, okay, it's the period in between. Look, so let's do in between. Look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Or did I count that wrong? Oh, no, let's see. 1, 2, 3, 4. Oh, it said 2005 to 2017. All right, hold on. Hold on. I got to go back. Hold on. I want to be clear. Hold on. All right, 2005 to 2017. Now, let me go back. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Everyone got that? Okay. Now, it's 13 minus 1, so that would be 12. Is everyone clear? Okay. So this is what it comes out to. So this would be 1 over 12. Now, let's go back to the problem. And I hope I can still bring that problem up. I did have it up. All right, hold on. I'm going to stop for a minute. Okay, so now I'm on problem 10 of 10, right, from chapter 10, which is really problem 10-7. The last 4 years of returns for a stock are shown here. Now, that should tip you off about something. If there's 4 years, when we use the equation, we subtract 1. Now, let me show you that. All right, here's the average returns, right? We don't fool with that. We just take the average. Everyone see that? It's 1 over 4. Now, the variance, it was 4 minus 1, which became a third, if you look at that equation. And then you multiply that by all 4, okay? So that's why this is a 3 and not a 4. It's minus 1. And then you just take the square root of this to get the variance of the standard deviation. I hope I'm clear. If I'm not clear, just let me know, okay? Alrighty, thank you.